Okay, now let's look at these discontinuities. These top ones have asymptotes. They're also discontinuous. This first one is discontinuous because of the asymptote. Now they both approach positive infinity coming from the left-hand side and coming from the right-hand side. They both approach positive infinity, but it's still discontinuous. I cannot plug in 2 into this function to see what it's approaching. Because if I could, then I know it's continuous. This one right here, it has a limit, or has an asymptote, and this approaches negative infinity, it approaches positive infinity. Again, I can't plug in 2 to find the limit. And here, check this out. I can't plug in 2 to find the limit either. No, I cannot. Now, if I go from the left, if I say, what is the limit coming from the left, I can plug in 2, right? You can, because this one has left continuity. Ooh. So this one has left continuity, but there's still an asymptote here, right? Okay, so it's still an infinite discontinuous function because it has the asymptote. Going from the right-hand side, it's approaching infinity. Okay, and this one down here, that one is discontinuous in another way. Because this little point right here, if I drag it across, it goes up and down, up and down, and up. It starts jumping back and forth, back and forth. It does not approach anything, so this one doesn't have. This one's not continuous there either. Okay. Another thing that the book gives us, and it goes really into detail on this stuff, but I don't think it's necessary. I mean, what are they trying to show you here? They're trying to show, hey, if you have a function that you could split up into 2 parts and add them together, and both of those functions are continuous, then you can split them up and solve it. I'll show you some examples. Here we have k as a constant. It's multiplying. So if you have some function, like let's say you had 5x squared plus 10, I could take out a 5 here, right? And then that wouldn't be 5, that would be 2. So it would be 5 times x squared plus 2. Now you just have to find the limit of that one and then multiply by 5. I mean, I don't understand why it goes into detail about these problems, but anyways, I'm talking about it. So, you know, if you guys try to read the book, you understand what it's saying. If you can split up the function into 2 different functions that multiply to each other, and those 2 functions are both continuous, then you could plug it in. Blah, 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 blah. So what does that say? That says, well, let's get practical. Let's see it. We're just going to go straight to practicality here and stop talking of theoretically. All right, now sine y. Can you guys split that up into 2 functions? No. So in this case, you just have to think about what this graph looks like. Sine y. Are there any gaps in it? No. Are there any asymptotes? No. Okay, so you know that this function is continuous. Now, if you know it's continuous, that means you can just plug it in. You take this guy and plug it in. This means, because you know that this is continuous, you can go take that function and you can plug in pi over 3 to get your answer. And if I plug in pi over 3 to my sine y right here, I get red 3 over 2. Sorry, your drinking of the water bottle distracted me. Yeah, I know. Okay, so the next one, we can look at this different ways. We have a function right here, we have a function right here, and we have this bar right here, which is like another function. We have all these functions. So let's graph this function right here. You guys know what that graph looks like, right? It kind of goes like this, right? That's the exponential function. Okay, now if I look at this one right here, we have the x plus 5. If I graph, yeah. Sine of pi over 3 is not 1/2. Oh, that's cosine, yeah. That's okay. No, thanks for looking out, though. Okay, now if I look at x plus 5, I can, that's x plus 5, right? It's just a line. Okay, and then the last one, this square root, the square root sign is a graph that looks like that. So are any of these graphs discontinuous? No, actually, they're all continuous. Now this one has a kind of a limit, like you can't plug in negative numbers, right? So because you can't plug in negative numbers, that puts a limit on what our domain can be, but we still have all continuous functions. Now you just have to make sure that this does not equal 0 on the bottom, and that's kind of obvious. If you get 0 on the bottom, then it's undefined at that point. You can't find the limits. So why are we doing this? Well, we're saying if you look at all the different parts of this whole function, you can split it up into little parts or little functions. And if you look at each of those little functions, if all of those little functions are continuous, then you can just plug in the -1 to get your answer. So we have 3 to -1 over -1 plus 5. And so let's see, the bottom we get 4, so that's going to be 2 on the bottom. And on top we're going to have 1 divided by 3 because the negative exponent flips it. And so this says 1/3 divided by 2, which is the same as multiplying by 1/2, so you get 1/6.